All right, everyone, we're gonna get started. So, before the break, I left you with this challenge here, and we'll just quickly go through what this answer actually looks like. So this would be what a regex looks like for a student email, right? So the caret indicates A to Z, right? So any letter from A to Z, we have exactly 4 letters. And then we have the \D, which indicates any digit. We have exactly 4 digits. And then we have @student \dot. That means that we have to have a dot there. So we call that / indicates an escape character. \dot edu, and this $ indicates that it ends with the @student.monash.edu. Okay. So this would be a pretty straightforward way to get a student email instead of a staff email. Now, before we move on to dictionaries, just some quick tricks that might be useful while you're coding. So say we have something like this. Obviously, we know that if we highlight this and we press tab, then it tabs the whole section. Now you can actually press Shift Tab to bring it back. Okay, so it's a very sort of neat trick to use, particularly when you're dealing with Python, and it allows you to very quickly modify sections of code. Now, another trick as well is if you press Command on Mac or Control on the PC, then you can actually go to the end and front of each lines as well. Okay, so that is just sort of useful tricks because when you're coding a lot, this is the sort of stuff that saves you, milliseconds or seconds. Okay, cool. So moving on. All right, so let's go through the final key structure we're going to go through today, with its dictionaries. So dictionaries work very similarly to real life dictionaries, where you have a certain key, so we call it a key, and then you have a value, which is the actual entry. So for example, in a real dictionary, the key would be the word you're looking for, and then the value would be the definition that comes after it. Okay, so it attaches a value to a key. So let's say we have these 2 components here. So one is a python, which is a large non-venomous snake, and an anaconda, which is a semi-aquatic snake in South America. So Python is actually the name of this language we've been using. It's actually named after Monty Python, which is where Python came from, because someone thought it would be funny to do that. Anaconda is an installation package that you can find with Python. Okay, so someone also thought that extended the joke. So the left side are our keys, so Python and anaconda, and then the right side are our values. So how I think about it is it's like a key that unlocks a value. Okay? So this is how we define a dictionary. So the first thing is that Python accepts or understands that you're trying to create a dictionary if you use curly braces. Okay, if you try and use square brackets, that's obviously going to create a list instead. Okay, and Python will get very confused because the structure of the dictionary is very different to a list. So how it works is you have the key first, which in this case is a string that says Python, followed by a colon, and then the value in another string. Okay, and the keys and key value pairs are separated by a comma. Okay, yeah. It doesn't have to be a string. Yeah, so it can be all sorts of stuff, and we'll go through what it can be, what keys can be, what values can be. So it is comma separated. Okay, so we have a comma there, which indicates another key value pair. That's what we call these key value pairs. That's a key value pair there. Now, keys have to be unique. So you can't have 2 Python entries, for example. Okay, values don't have to be unique. So for example, if we change anaconda to a large non-venomous snake as well, Python is perfectly happy to accept that. Okay, but it cannot accept a second Python. Now you can create an empty dictionary, so initialize an empty dictionary just like so. So it just uses curly brackets with nothing inside. And then you can also do something very similar to indexing with dictionaries. Okay, so say we have a dictionary with spirit animals. Mine is the koala, James is the dog, and Alex is the panda. Okay, so if we index spirit animals and we index James, what do you think comes out? Dog, exactly. So if you index the key, it returns a value. Okay, So sort of think about it like calling a dictionary, right? If you have a dictionary, if you call a specific word, it will return the definition. All right, say we do this instead. We add Chunju. His spirit animal is also a dog. What happens to this dictionary now? So remember that this is an assignment operator, right? So we evaluate the right side first, it's just merely a dog emoji. Then the left side is in the dictionary, we add a new entry for Chinju for a dog. Okay, so that is how you add entries to a dictionary. Yeah. So it's similar to an index, but indexes refer to numbered indexes. This one is not really a number, right? It's just a word. Okay. So you can also draw values out of the dictionary and then do something with it. Okay. So in this example here, say I define a dictionary where my favorite number is 22. Okay, I can then decrement that number by 2. So recall that the decrement operator in this case is fav numbers qua equals fav numbers qua minus 2, right? So we're evaluating the right side first, which is fav numbers qua is 22, minus 2 is 20, and then we assign the new value to 20. So if you try and print fav numbers at this stage at the end, then it'll say my favorite number is 20. Does that make sense? Okay, so it works very similarly to other data structures as well. So we can change a value by using the similar index function as well. Okay, so for example, James's spirit animal right now is a dog. I can change it to a cat using the assign operator. Okay. All right, now what happens if I try to call Andrew's spirit animal? It returns an error, exactly. There's no key in there that says Andrew, okay? And so in this case, it will say key error Andrew, okay? Now that doesn't even matter. Say, for example, somehow one of the values is Andrew, it will still return this error because it's looking for a key when you're putting in this thing, okay? All right, other things you can do as well. So remember, we managed to look for the apple, banana. We asked if A is in fruit, right? We can also do the same thing, which is create a Boolean, which says Alex in spirit animals, and this will be true. Okay? If, for example, we say Andrew is not in spirit animals, this would also be true, because Andrew is not in spirit animals as a kid. Does that make sense? Perfect. All right. Say we add Paula. Instead of an emoji, we add the number 5. What will happen? Yeah, exactly. So there are no restrictions on what can be a value. Well, there are some, but we'll cover them. But in this case, you can simply add the number 5, and it can just behave and add the number 5, even though we've defined it as spirit animals. Okay, so just add value. All right. So building a dictionary. So one of the only way to pretty much build a dictionary is either, or sorry, 2 ways. One is to define from the start what is in your dictionary. So you see the first one is we've just simply defined it from the beginning, what the whole dictionary looks like. The second is you create an empty dictionary and then you add stuff slowly, okay, line by line. Okay, so those are the 2 main ways of building a dictionary. So how do dictionaries work when it comes to for loops? So recall how when we had lists, we had 2 options, which is for each index. So we index through the list, so 0, 1, 2, 3, each index, or we can loop through each element, okay? In dictionaries, because there's no number, there's only one option. We have to loop through each element. There is no inherent number in the dictionary, okay? So there's no index 0, index 1, or anything like that. It's just individual elements. And dictionaries are also iterables, which means that you can use a for loop over it in Python. So in this case, say our spirit animals is Qua is a koala and James is a dog. You can write for key in spirit, right, which is for every single key that comes up. The value equals spirit key. Okay, so you have to draw out the value, for example, using that technique. There are some other smarter ways to do it as well that I'll show you later. And in this case, would print with an F string, key to value. Okay, so what would print in this case?
Color,
Color?
yeah, arrow, color, sorry, and then it would have line, and then it'd be James.
Exactly. So let's go through and step through what this looks like. So for key, so it says that we're going to iterate the first time. It's going to iterate through. It's going to return this. So it's going to assign key to qua. Does that make sense? In spirit, so referring to the dictionary, value equals spirit qua, which means that value equals qua. Does that make sense? And then we're going to print qua, arrow. Okay. And then it will do the same thing. So the next time, key will get this. So key equals James, spirit James equals dog, right? So value equals dog. And so we'll print James, arrow, dog. Okay, so that's how you iterate through a dictionary. All right, another very great way to do this is Python allows you to directly pull out the value in the for loop. Okay, so how this works. So instead of having to draw value out in a separate line here, we can just directly draw it out as key, comma, value, and it will return the keys and values for us in a single sort of motion. Okay, so the first time it iterates, key will be assigned to qua and value will be assigned to koala in one step. Okay, and then it prints it out. And then the second time, key will be assigned to James and value will be assigned to dog, and then it prints it out. Okay, so this is a very neat way to for loop for a dictionary that is very short. Okay, so you can just simply say for key value in dictionary. So we talked about mutability quite a bit today. Dictionaries are mutable, meaning that if you modify it in a function, it will change permanently. Okay, so any complex data type or any data structure, if you change in a function, it's a permanent change. If it's a basic type, so for example, a string, an int or float, if you change in a function, it will only be temporary and the function will throw it out afterwards. Okay, now keys have to be immutable objects. Okay, so the only acceptable keys are ints, floats, and strings. Values can be literally anything. So your value might be a dictionary itself, might be a list itself, it might be an int, float, or string. Okay, so that's a really important distinction. Keys have to be basic types. Values can be either basic types or complex data structures. All right. So let's talk about different dictionary methods that might be useful. So if our dictionary is Qua's spirit animal is a koala and James is a dog, then dict.keys will return the keys. So it returns the keys in an iterable, which means that you can actually loop through it in a for loop. Okay? If you try and print it, what's going to come out is a list of all the keys. But actually, it technically isn't a list, but it acts a little bit like a list. Okay? If you try dict values, then it returns just the values. Okay, so you can use those functions to pull out just the keys or just the values. All right. So to delete something from a dictionary, say we define dict again the same way. If you delete dict qua, then it deletes that entry. Does that make sense? So that's how you delete items from a dictionary. All right, if you try and get the length of a dictionary, then it returns how many key value pairs there are in a dictionary. Okay, pretty straightforward. All right, so working your teams to create a function called word counter, which accepts a string passage, counts the frequency of words in a dictionary, and then returns the dictionary. Okay, so for example, if we do it sort of manually, it appears twice in this sentence. Was appears twice in this sentence. The appears twice in this sentence. Of appears twice in this sentence. And times appears twice in this sentence. And then best and worst appear once in this sentence. Okay? But that's what you sort of want to get from this dictionary. Now, what's really interesting, and this is very much a side note, is that if you try and input the English language into something like this, what you get is a sort of exponential looking graph like this, right? Where words like the, of, and a are most common, and then it keeps on going down. But it actually isn't an exponential curve, but what's called a Zipfian distribution, meaning it's a very special type of exponential curve that seems to be present only in the English language or potentially other languages as well. And yeah, so that's a special type of distribution that if you try, sending it thousands of books, you're going to get something. Okay? But yeah, have a try at word count. No case, so assume it's not case sensitive. So you accept the sentence that could have uppercase letters, still need to bring it down to lowercase. Oh, it's the same thing. Yeah, it's for NLP.
And then. Yeah, no.
So if you're confused, think it through step by step what you would do, right? Well, the first step, particularly for more complex functions, is to just list out the 4 or 5 steps this would probably take and then do it out each section.
Then we define what.
Yep, so, yeah, so think about each letter, right, so it's like, the first time you have a play, what is
Like on here. There's a bunch of different. Like presumably things. I don't think. That's what I thought of. Yeah. Wait, I'm gonna let make it.
I'm just gonna figure out how to.
Wait a minute. I'm gonna. This is just a little more wordy about it. Word, lots one. These days, we make that. I think it's like four times. The unit can be. Oh, oh, yeah, the name. Oh, it puts it in the loop. I accidentally put it in the loop. Oh. Wait. Hey, yeah. Come on. Yeah. Well, but it does it again. Ah, yeah. He said it's. Very easy. Yeah. Time. Behind the other button, like,
Well, because you see it's a video.
yeah. The lid.
That's the two that shows you have the options. Yeah, this is so probably at least that. So you.
How people,
Once you have that list, you like do that list. First time you see it.
yeah, so.
Yeah, if you see it.
Unless if you really stop or lose. Yeah, I know, but we also have to release it. Like, we have to be close. We can't like double up. If one, then it becomes late, and you can't skip it. If I get, how do I get the top of that? Just remove the least thing, right?
So they go off matches so long.
Like, what if I did it? That one? Yeah. We stop X is not a hit. I think it's.
Final is it all places.
Right. And then go. So you get it, you can make one.
Alright, sorry. Is it just because it's?
And you have. Was. You made a list. All right.
Yeah. So
We don't have. No, there's no way. Well, I just don't know. We're iterating on it. Last one, and new classified. Yeah. So like you're inside of the chain. No, it's okay. I'm just trying to like. I'm all about it. That's the mistake. Okay. But there's no freedom. Pick the word, if it's not if you return, it's not. One sec, if one exists, it's a thing. Return does not exist.
Oh, okay, so the comma is like.
Yeah.
Can't see what's like that.
So you're really like, yeah. Let's say you say certain
Yeah. Because it's not gonna be really complex.
I've got it to the words. Wait. What's words? Anyway. Did this. And it makes love hair. What are these words supposed to be able to? Okay.
Yeah. Because you know that part like exactly. Because why I think we live inside of bunch of different strings. And then like that you should make way for the oh, but you need to do banking here like wait on this.
I write
The problem is, this, there's only gonna do one. Not gonna do it right, it's like, I don't know that one eye. And then it's out there, well, we just make it straight, so what we use in this web, like these screens, and it's gonna be like, actually, what I. It's like the user first. That if you do some.
Yeah, sure.
And then. Stop. Otherwise. Let's say.
Each element of this, if element is.
Oh, okay, yeah. Drain.
I'm not sure.
Yeah.
Yeah. So, it starts, you know, it starts with, I don't know, it starts with.
Yeah, it's fun. That's a mess.
So, imagine this. So, think about the one.
Sure. So this will figure out something about that. But by then, we will think through the finance definition, which is what we see once we look in that right? Why would we want? No, again, and I created this new and if I want to be remembering and this is the biggest company. So what it's creating is basically just public all power for impact. So every single election. I think if it's not conservation, it's not the new right? And then using that, we can then since there's no white space, we create a list with one item and it's one item that was one. We create so at this point, we're gonna have a list of right? Okay, so yeah, at this point, we could sort it. Oh, yeah, but that, that's just me. Yeah, so it looks like the amount now this all goes into it.
So, if you're
Without punctuation, there's no like. And then we move here, well, now we have it. Let's see one of these words, one of these words. And we check it in the dictionary. Dictionary is not something. This is the dictionary. It's not, we actually.
You don't actually know any languages because.
And you know how, when you add a dictionary, dictionary, you write something that doesn't exist in the dictionary, and you give that.
So this case, remember that very something happened. Say this is like right, just that's not what it's not to one. So you have the variable here. This is where you sort of think about the logic that you're saying that word for the person.
Or you make it look like. Yeah.
Yeah, exactly.
Oh, yeah, because it is.
I don't mind. He doesn't have that. Damn. Yeah, no, I. Hey. So like, why? Oh, why do you need the right? Notice really it's in the middle of right. And then she's like, it's reading them. Ah, yeah. Yeah, I know. I'm trying to make it. Like, yeah, letters. There's like, what about like his notes? That's like. Yeah. Yeah. Well, maybe. Yeah, you can have there's a sort that it goes out. You want to say,
Oh, okay, okay. So it's not.
again, I didn't. I'm walking so really, on the back.
Oh, yes, this is where. If it's already realized.
That means you can. Alright, so. The first one. Yeah, that's where you get it. That's not. I'll make sure. Yeah. Oh.
Oh, yeah.
Yeah, it's kind of like you don't need to like you're not like this. It's like the last it's like basically Yeah, and then it's not like specifically like that. Wait, then it's not that. Yeah. And how I-
Yeah, so.
Yeah.
Yeah, this is not really- yeah, this is-
Yeah. So if we want to. It seems like.
Yeah.
Yeah, but it's like as soon as you email all of the.
I don't know how much. You're using much.
Okay.
Alright, so it's just like.
Yeah.
Put your. Yeah, you can emphasize. You can see us just on chat.
Oh,
Yeah, so one way is.
Doing a little bit too much, I'm not.
Punctuation, I guess. All the bases. Then she's trying to actually make it look better. No, it's a single print demands. I get this logic, when you write it down, you also.
we can also go down.
So it's not to me.
Yeah, you.
Right, this.
No, do you want to sit somewhere else?
Yes.
Is that what you're looking at?
That's very simple. Yeah, I don't know how to use it. Get rid of the mark. Yeah, so that's what we were. You guys like on this one.
Yeah.
Yeah, bro.
I think you want like.
That's actually insane. That's right. That's right. There's something wrong with you. Yeah, you're making a lot of money as well.
No, but I'm saying.
Oh, next week's a lot more expensive. I was thinking you'd be 16 or 20 schools. That's insane. That's extremely. That's okay. That's extremely, no, that's, I would say that's extremely bad. No, I would say it's spectacular. And I would say, I would be like, I want to break it down. I'm very interested though.
I was like, oh, it's okay. It's so measured by it. Have my very. Fine.
But then you.
It's one of those weird questions.
Fair enough, thank you.
That would be much like the same. Oh my God.
Nothing new. Obviously. Yeah, or like
He's actually doing the opposite.
Oh, mom makes a lot of sense. Oh, that's actually why.
Yeah. Oh, do you guys?
Yeah, yeah. Yeah. Well, you over this?
So do you
I'm right. Yes, no. Ah, okay, well, I was talking about. Okay, so he has no young. Unless you do.
Yes.
I'm very. Yeah. Oh, from like. The TV yeah, so you have yeah.
Oh, yeah, that's classic water set that everyone knows.
You told me about this. They have these shitty.
Oh, yeah.
Oh, so these are all country games.
Yeah, I'm so sorry.
Hey, no, I'm just saying, like, no, I'm not hating, I'm just saying, I think like you said, that's why I'm like, yeah.
I'm sorry. Man, very, very long. I'm gonna lost. Female. And but I think he's back to be good at the guys.
Yeah.
I was like, okay, we're. So anyways, it's not that deep. Someone did tell them, I'm gonna go. It's funny, what I mean. I'm sorry. I'm using date or use only. And because you have to use it out, I'm not going to use for the camera. Because one of the call you can take home, she knows also they can do computers and everything.
There was, Val.
And also she lied, and also that's really lied and being separated. Then without the time when the panel decision with some allegations. They're like every time it's beginning. Like she before that person brought up the she brought up conversation.
No, what did she say? What had
She was like, oh yeah, like.
Yeah.
Yeah.
But she doesn't want it, what I'd say. Crazy though.
And then that.
Because he obviously didn't say that.
No, then. That's like, oh, I mean, anyways, now, 25.
Hey, maybe we can do this.
Aha, yeah. Yeah.
You guys are listening.
Yeah. And I would say
You can't. Not convenient. I just did live for we get the again that we saw that right.
Anyway, it's not, I'm fine.
Yeah, yeah, yeah.
Because, top.
And then pay them. Yeah, yeah.
Yeah, they don't have any technical. Because apparently some people. But like everyone gets. Right, that's like a pretty. Yes.
Yeah, we don't do those stuff.
You don't really get to. Your analysis, you know, I think every
We did them.
Okay.
How does it? You know, like.
And then they'll like.
This example. So hopefully everyone had a chance to work on this. So we have a function here, word counter, which accepts a passage, and I split it into this workflow. Okay, so step number 1 is to create a dictionary. Step number 2 is to split the words. Okay, I've omitted removing the punctuation just for brevity in this case. The third is to go through each word. The fourth is if the word is present, you increment. If the word is absent, that is, we're seeing it for the first time, then we have to create a new entry. Okay, so let's take a look at what that means. So I create a dictionary called counter. I split the words. Okay, so words equals passage split. Now, recall that when we use split, it returns a list of the split strings to us. It's something that's very nice to iterate over. We then go through each word. So for word in words, if the word is already present, so if word is already in dictionary, then we increment and we call that plus equals means that it's counter word equals counter word plus 1. So counter word plus 1, in this case, say it's the second time we're seeing the word it. Counter word is once because we've seen it once already. We add another time, so it becomes 2, and then we update the dictionary to say 2 instead. Okay, so we do that in a single line. And then if the word is absent, we have to create a new entry, which is at 1. Does that make sense? Okay, and then we return counter because we want to return the dictionary. All right, so let's go through this bit. If we go through it step by step. So we split the words into different words or different strings. And then for word in words, so we go through each word, it appears for the first time. Was appears for the first time. The best of times. Right? And then we go through it again. So it now updates to 2. Was the list is a completely new word of times. Okay? And that's how you create a little word count. All right. Now let's try this exercise here, which is potentially a little bit more challenging. So write a function which accepts a dictionary and returns a new dictionary with the keys and values reversed. Okay, now one thing you have to be careful of is that you can't have the same key. Okay, so remember in spirit animals, I can't have qua twice. Okay, qua can only appear once. Okay.
I don't know.
I'll give them no, I'm not. I'm not sexually driven. I'm not glad. Yeah, I'm not this house.
So think along the similar logic lines we had before. If the key's already there, what do? If the key's not already there, what do? Yeah, let me just run the, yeah. Yes, I'll just show you. Yeah. Okay, so just to clarify as well, as you're thinking about this problem, right? I've written it on here. If, for example, we have Qua is 2 and James is 2, when we try and reverse it, it should be a list that is inclusive of both Qua and James. Okay.
Oh, so if they have the same.
Yeah, if they have the same value, then when it's reversed, the value of this new key needs to include both the original keys. For now, I think just I think that the best parts, when I'm at the dictionaries, the values can be technically, like it's very difficult to reverse it in complex stage. Outlets. You know, just need to really yeah, so just see. Yeah. There's some more complex senses. Yes, it's all key common. Yeah.
Usually I'll.
Or you addiction. Person, is other.
Right, so just a correction, everyone. So I think with the version of Python that you're using, in order to accurately call out key and values, you need to have this dot items at the end of the dictionary. Okay? So you can't just do like key value in dictionary, but you have to add this additional dot items operator to basically get key value pairs out. Okay? So that might be a useful piece of information, especially for this task.
I'm just taking the first bit. That's four things.
Oh. What's it now doing? It's not built, it's not like ways where you are signed down to our events or something like that. When they are not even.
I thought I haven't got it. If it's emo, it just makes it. If it's not, it is the only thing that it down. And yes. So if this is already, because that's why now. Because I tried to do this. Well, yeah. So add something to it. All right. Yeah, see, I tried to do that originally. My way. Or actually, it wasn't misstating. Well, yeah, so I guess, but I thought I didn't have it. You can also add I. Yeah. It might be. All right, let me. Yeah.
Okay, so that's.
You see, not he's so much. Oh, yeah, I was too high. I didn't hear about it.
They just know that that's about it. Yeah, that's fine. You haven't defined heating value either. It's heating value. I guess you can talk about it. But then we'll probably the heating value, just a bit, yeah. Okay, so it's. That's why I'm.
Yeah. I think the value of wording this, you sort of says.
You just.
So. Very close to so.
Reverse.
Right. So it's saying, you see how it works.
So this is the value that's now.
That makes sense. Yeah. And you should be able to follow the dictionary. Yeah. Feels lucky.
Yeah, which is why I wanted like this, so if it wasn't a voting dictionary. It's the thing that I'm-
But he's not the OG. Yeah, that's not OG. Well, why you didn't do this?
Because I know I should have, I'm just saying that I'm 45 rated. I can figure out what I've done.
Alright.
Another way to say it. Listen.
Oh, I just need to. I made the initial one of these, and I just gave you. Ah, this one. Oh, that is, yeah, put the key in this. Yeah. Yeah, that's should be helpful.
So one way you can do that is I just. See how that's. Yeah, that's what. Yeah, so. So the question is. Yeah,
So if the value.
Why would you add, why would you make the?
I would make dogs.
Oh, we're going to the thing that doubles up dog.
Yeah, that's what I'm.
Yeah, yeah, yeah.
So what I'm saying is I make this, dog, 1, 3. So right now, the usage is replacing the number of one.
Yeah.
Yeah, so what's my concept? Yeah.
That one. Well, I don't Oh, you have to give them a question. Yeah, you give them.
Oh, because.
No, I also make it safe. I am. No, Is the vehicle in front of you? Oh, it can't be in line.
Oh, shit.
Ah. Yeah, so after, yeah, see that. Right.
Oh,
Yeah, yeah.
Just so I can house.
Ah, every time. You want to, you available.
Tonight. Yeah. I don't know. That's not.
And then like, yeah. The maple.
Records around the key. So weird.
So I was trying to like a reassignment job. It's more. So in the end, saying that like, what am I? Wait, when I'm trying to. What it, and then whatever just codes that when it doubles up, it's not.
The thing is, you don't want
Yeah.
Oh, because what it's gonna do is gonna return tracks. Pretty sure. Dictionary. It's working, but it's not. But I don't think you wanna keep them to the dictionary. Yes, I mean, oh, okay, so you made them, dictionary. Let's just. Okay, that's. Yeah. Oh. And then, as I mentioned, it's kind of the graphic dictionary. And you can actually get it actually, it's like, but it's defined, and it's like, so Oh, okay, I see.
Value. So I think that and the value is like I think the key is this I'm gonna actually put it together. So so the value, yeah, right. So ideally, what I is I made a business in the right you get the right.
Oh, okay.
Instead, I feel like if you are meant to get you should make this side function. And then put the 10 lines. Yeah. Because it's only one.
Okay, so it is your.
Yeah, now you can work on that. Because it's so you can put the value as a when you
I'd like to know, so
yeah, because you have buzzer and then there's so many things in this because they keep this by and also if and the value my so you need one for me my net empty for that if this this is what it is a new one you need to check because your keys cannot be like you cannot say right you need to check I have yeah so okay this one this I just then I did check if I do if not if it was I usually get small not a resource it is not if it is in the so it is not yeah not again
Adding things.
Oh, then I need to do like.
So we can the value of this and for example because so because the middle key first so you use that thing is the value yeah new ones okay so the value becomes because you need to make it this right. If two is the key, your value is the least of yeah. So you make an empty so if you know that key is not so you create a key empty list. Then the next time you come to you will see you already added and I believe that is easy. Yeah. So our empty can which is included in that works, right? all the values the previous security values. So then I'm iterating through these.
Yes, that's right.
To see if in reverse, then if they are in reverse, well, actually, these ones, I wanted to add. I wanted to add.
I think it's really
Yeah. She's got it, like, I got it, yeah.
I don't know how much that's saying.
It can get like one, but I wanted to separate it as a big stuff. No, but anything that makes you part of the platform, then yeah, can be. And then I'm saying, key on, I'm really lost. And I will check, but yeah, really now, I've got I just need.
So you're kind of walking around it.
Oh. Because I tried, what I tried doing before was,
So you need to make it. What you can do, okay. Yeah. This one.
no, no.
How did you get to that? I'm still smoking that one.
Actually, I'll.
Yeah, just push the. Then you.
Yeah.
And so even if you can't that this cannot for you. So you can just start. You already make it to this, and then use the pen and try it there. I need to use some pen. Same. And then another because it's already done.
Oh, so that it might already I'm like, how does it work?
Yeah.
I'll show you what I'm saying. I have a very where it's not red fees off the value. And then I'm trying to iterate these things. Unnecessarily. Yes, this doesn't make sense.
What's one for the. Yeah.
Yeah, exactly.
The second one. Then it would be what your best. Let's first.
I don't know what you want.
Yeah. Your best year or. There is no. Yeah, right. And then
Oh, I don't mind why this value is going to be same. Because you cannot have too many other pieces.
So then. Yeah. Yeah, so now try. That makes sense.
I think that's
How you understand it? I'll come back to that. We don't even need to make
Playing that perfect. Where we're spreading to time.
I already have that.
Yeah.
So you can't think that up and down. So that's
This one, I'll give them a say. Yeah, so entries, and then I've got, this could be anything. It's just true error, and it knows the person maybe gets to do. That's why it's. It's arbitrary. But just for the sake of that, it's gonna give you the second value, which is the. What was so. Oh, you don't need that. Yeah. That's why you want to elevate. So besides everyone, so then you want to make another. And it comes and yeah, you would have yeah, so it's one say that yeah, but I don't know. The value is going to be the
So right now, it's the value that is, it's the value that. So you want that.
Yeah, I think it's like.
So you need to use the track that. Yeah. Yeah, you see. Can you?
Should I get my head off? They used to. I go to pick up there. That's like my second.
Oh, this is so long.
I'm gonna try and get like my side. I'll do next. That's what I'm doing. Yeah,
Yeah.
Yes. Should I get like it's either, you know what's that? It's either that, it's either that or I get like about that. I was like, I might have to roll it just like a day. Like a small like. I know. Oh, okay, yeah. Yeah. Okay, if I can only chance. Pretty sure it'll sit on. Very neat. Like I know it. I mean, we're trying to basically. That's why I yes, I thought. Yeah, you need to. Stop that. I'm fine with that.
I'm so very impressed. We won.
No, I appreciate it. You guys thought the.
We're gonna go through the example real quick and then have some finishing slides. Okay, so this is a particularly nasty example. So if you found it challenging, don't stress. It does require a lot of knowledge about dictionaries, lists as well. If you want to go through the slides afterwards, just see if you can understand it, right? The project is not going to be this challenging tomorrow in terms of manipulating data structures, but it is something that is actually useful in real life. So in the yellow pages or the old times, right, you actually had every phone number, and then next to a phone number was a person. But if you take a look at your iPhone, it's now switched, right? You have a contact and then all their potential phone numbers. Okay, so that's sort of an example of where you can actually use something like this. So, let me switch forward actually. Realize that I went back. Okay, so say we have an original dictionary that looks like Part 2, James 5, Alex 2. We want to reverse it whereby the values are stored in a list. So this is what the code actually looks like. So let's run through it step by step. We firstly create a reverse dictionary, okay? And then for every key in the original, so that is for Qua, James, and Alex, we're going to go through a certain logic, okay? So value equals original key. So in this case, I haven't used the 4 key value loop, but I've just drawn out the value from the dictionary. So pretend it as if it's a 4 key value loop. If the value is not in reverse, so we don't have any entries for the first time, we're going to create a list and then append the value to that list. Does that make sense? James, in this case, we're going to go through the exact same logic. And we're going to create a new list with 5 as the value, and then append James to it. Okay. Now what happens when we have Alex? And Alex has the exact same value as Qua in this case. In this case, this if would be false. And so it ignores it, and it simply appends Alex to there. Okay. So run through that at home. It's a bit of a tricky one. But it is worth sort of understanding because this challenges you in terms of list understanding as well as dictionary understanding. Now, dictionary time complexity, keys are 01, values are 01, so reading keys, reading values are very quick. Getting the length is very quick. If you iterate, it's simply ON as well. All right, now we've completed data structures and we've gone through lists, strings, and dictionaries. But there are other types. So in Python, it also supports 2 other types. The first is called a tuple. So a tuple is recognized by Python as a curved bracket. Okay. It has slightly less functionality than a list, but it requires a lot less memory. So you might see it particularly in production code when you don't need a lot of memory, / you don't have access to a lot of memory. You might also see sets, and sets are represented by the curly brackets like a dictionary, except it doesn't have a key value pair. So if you miss a colon in a dictionary, it actually interprets it as a set. And what sets allow you to do is allow you to do set map. So for example, if you want to intersect, union, that sort of thing, it's very, very quick, very powerful for set, and it does it in 01 time. Now, we haven't talked about this, but other languages have a lot of other data structures as well. So if you ever do C or C++, you may run into what's called stacks and queues. And so how stacks work is that you push an item onto the stack, and then you can only access the top that you pushed onto. And then you have to pop out that item. Okay? How queues work is you add something, you enqueue something, and then you dequeue near the end. Okay? So they're slightly different structures, and that this is first in, last out is this one, and first in, first out is that one. Okay, so just think about a queue. If you're standing in a queue, the person who's come in first will come out first, right? But with a stack, whoever recently came in will come out first. All right, now quick sort of section on packages, just to sort of tie everything together. So Python is very powerful because it has practically unlimited packages, okay? And we're going to be talking through some of those packages tomorrow morning before your project. Now, Python itself has a standard library, which is a library that is available in all Python. So for example, it's the string library, the RAM library, all that stuff is pretty standard. And they're extremely optimized. So they're written by really top engineers who have pretty much shaved as much as they can time-wise, memory-wise, off these functions. You also have third-party libraries, which are very powerful. So other people which are not part of the official Python team also release all these packages as well. And that's one of the reasons why Python is one of the most powerful languages, because lots of people release different packages for it, right? You can find almost anything for it. So let's go through what a package looks like. So at the top here is a library, right? So that is a set of packages. And then underneath that is individual packages. And then individual packages have multiple modules. Okay? So let's go through what that actually looks like. So one thing that we'll be talking about tomorrow morning is a package called NumPy or numerical Python. NumPy has multiple packages called array and random. And then array itself has individual modules called array and transpose. Random has randint and randfloat. Okay, so these are just standard mathematical stuff you might see. Now, how to use packages. So standard popular packages require import. You've been using import. You've been playing around with import. If you want to use a different package, you generally have to import it. This is something that's very, very common. Less common third-party packages also require you to install it. Okay. So how to install it? The first is to read the instructions. And anyone who releases a package actually provides instructions on how to install it. If there are no instructions and you just want to randomly try, you can try something called pip install package, right? And that basically often works in installing the package, but it can be a nightmare at times. So we'll cover more of these skills in the summer course in terms of dealing with potential conflicts with different packages. Because to do something that's 1,000 lines long or 2,000 lines long, you need to rely on a lot of different packages. Now, how do we import? So there are multiple ways to import, and there's a substructure to how you import as well. So when you import NumPy, you actually import the entire library. Okay, but sometimes you don't need the entire library. Okay, and there are fundamental reasons later on why you might see how that can lead to bugs. NumPy has a package called random and a module called randint. Okay, or in this case, it can be a package, module, and then sub-module structure. Okay, so you start with the biggest thing, and then you go down to the module, and you go down to specific sub-modules. Okay, so Python understands this structure, and it's separated by a dot. So this is just an example of what that looks like. So you can say import numpy.random.randint, and it'll work. You can also say import numpy array.array, and it will also work. Now, another trick that you can do is we've been importing NumPy by itself, but you might see in code that people try to import NumPy as NP. So what that basically means is that instead of having to write numpy.random every single time, you can simply write np.random and it understands NP as NumPy. Does that make sense? So there are some common abbreviations that a lot of people use, and we'll talk about some of that tomorrow, but NumPy is always known as NP. There's another one which is pandas, which is always imported as PD. Okay, so you might see PD dot something, you should know it's pandas because everyone does it. Now, it's always good practice to specify specifically what submodules you might see, but often in practice, people are too lazy to do it, but it is sometimes good, and we'll go through an example of why. So in this case, we have numpy.rand.randint. It's often good practice to specify the submodule, but you might sometimes see import numpy as NP, meaning that you've imported the entire library and then you call a specific function. Okay, and let's go through why that might be bad. But before that, I've also seen this as well, which is sometimes funny, but might get you fired, which is you import NumPy as something completely different, like Dragon, right? And then you write Dragon around it, that is going to work, but it's also going to get you fired because no one's going to know what Dragon is when they're looking at your code, okay? Now, you've also seen this, so you may have also seen this, sorry, in old code. In older code, people used to write this from NumPy import rand, right? Or from NumPy import asterisk, meaning import the whole library. But it's considered bad practice these days. Okay, so the way that you should do it is always import NumPy as NP, for example. Okay. All right, so if we have the Python library and we have the random module and the random function, and we have the NumPy library with the random module and the random function, and then we call random, which random does it call? Right? Python, exactly. So in this case, we have Python library and NumPy library, so we've imported both, right? And we're trying to use the word the random function. and both of these libraries have a random function, by the way, it's going to default to the Python one first. Does that make sense? So it always defaults to itself. Okay? Now, if, for example, we write import NumPy and then random, what random does it call? Python as well. Okay, so again, it defaults to itself. What if we do this instead? Then this is how we get NumPy random specifically. Okay? Now, why is this important? Sometimes the functions actually have completely different behavior, right? You think that you're writing for NumPy random, but actually it just calls Python random, and then you start getting bugs. Okay, so it's just very important to be aware of which random you're actually putting. All right, so I've just written here that NumPy and Python actually have about 20 shared functions. So again, when you're doing mathematical work, you can accidentally invoke the wrong function many times, right? And a lot of people don't know what those shared functions are either. Okay, so it's something to do. Now, in the standard library, there's some really cool libraries that you can start to play with. And again, just reading the documentation, understanding how to play with it. So the first is math. We've dealt with math before. It has pi, e, trigonometry, logs, exponential. There's also date time, which allows you to play with the date, time intervals. Okay. JSON and CSV are great in terms of working with JSON files, which is very common in medicine, and CSV files, which are very common in research. URL-lib allows you to work with URLs, and then RE is regular expressions as you play with. Now, third-party libraries. NumPy is a very big one, which we'll be going through tomorrow. Numerical Python, that is really powerful for matrix computation. So if you ever have to do with matrix math, which you have to do with AI, right? Because it's all matrices at the end of the day. SciPy, which is scientific Python, that's for scientific computation. So if you need to use like a mathematical formula, like for example, a Fourier transform or something like that, SciPy is your answer. Pandas is excellent for data science and manipulation. So we'll go through a little bit of that tomorrow as well. It's a very powerful spreadsheet that's pretty much on steroids. Matplotlib is data visualization. And then Scikit, TensorFlow, and PyTorch are very common machine learning and AI libraries that are very powerful. And then Flask allows you to deal with web apps. So if you ever need to build a web application, requests allow you to download data from HTTP. And then Beautiful Soup, if you ever want to scrape stuff off the web, that's the sort of program you use for to scrape whatever you want from the web. Now, there's a whole host of third-party libraries. I tried to look at really bizarre ones. There's PyJokes, which provide one-line jokes for programmers. So jokes as a service. There's also PyChess, which allows you to play chess. Now, NumPy, just a quick note on this. So very powerful for linear algebra on data. It has extremely optimized, and if you recall from math, block products, matrix multiplications, etc. It's used literally everywhere in AI because it's, I think, like 1,000 times faster than most other libraries, which is a huge factor. Then you have Pandas, powerful for data manipulation. Import Pandas as PD. And then Matplotlib is really powerful for data visualization. Okay. And a quick note on reading files, because tomorrow we might cover some of this. So this is what a JSON looks like. This is very, very common when it comes to medical record data. Okay, so if you ever open up a medical record data and you actually ever get to play around with it, it looks exactly like this. Okay, so it's like patient name, who are, what conditions they have, what allergies they have. It's exactly in this format. Okay. And Python has built-in JSON reading capabilities, right? So for example, if you go data equals JSON.load open file name, they'll open up a JSON file, and I can't recall what file returns dictionary, that's right. And then how to save a variable file is using a dump function. Okay, so you dump file back into data back into the file. All right, now data is also often stored in text files, right? So text files are also very common. In this case, Python has specific facilities to open text files, and it's really simple. You basically just go file equals open text. What that returns is a special type called a file, right? Makes sense? And then for line in file, and that file is iterable, which means you can use a for loop, for line, print line. That's going to print every single individual line of the file. Does that make sense? So it's a very straightforward thing. All right, and a quick maybe set of questions about sorting. So how would you sort this following list in the fastest possible way, right? And this is a big question that a lot of people have tried to answer. Does anyone have any really quick ideas about how to sort this list? Because I know we're over time. How would you sort this list? Yeah.
Check if it's smaller or larger than the front.
Yes. So that is definitely a way of doing it, right? So quick note about time complexity. We've been talking about it. Time complexity is what's called a qualitative measure instead of a quantitative measure. So if, for example, it takes 5n operations versus 2n, it collapses down to O(n), right? And the reason for that is because to calculate precise either time complexity for very complex functions gets really time consuming and difficult, right? So you just want a rough idea of what it looks like. So these are standard time complexity measures that you might see in the wild, right? So O(1) is really quick. O(n) is the length of the list, for example, that it takes. O(n) squared is squared that. Log n usually means that you've divided the problem into something, and so it's logging down, right? Like it's like the log of the 2 to the power of something. And log n is something you might see, and the worst case is exponential, which is 2 to the power of n. So as it gets longer, exponentially gets less. So what would the time complexity of something like this be? O(n), exactly. So it runs through every component of the list just once, so it takes n times. Okay. What about this? O(n) squared, right? Because we're looping through once, and then for every time that we're looping through, we're looping again, right? So that's O(n) squared. So that's sort of a bit of intuition about how to determine time complexity. What about this? O(n) cubed. Okay, so this is n. We're doing it 3 times, right? Okay, so this is an insertion sort, which Barakat suggested, which is you basically compare each individual number with each one, right? And then you sort it based on where it is. Okay, so the maximum number of sorts that you can do for something like this is n squared. So the time complexity is O(n) squared. Okay, so it's a very basic formula that you can use. All right, this is another interesting type called merge sort, whereby you split a list into 2, and then you split again into 2, and then you basically zip through the values. Okay, I think the GIF actually needs to reset. But if you split the values, it's a technique called divide and conquer. You basically keep on splitting the array until it just becomes 2 numbers down at the end, and then you sort those 2 numbers, and then you work your way back up. Okay, so the time complexity of something like this is O(n) log n. All right, and then there's another method called quicksort. Unfortunately, the GIF doesn't reset every time I press it. But basically what happens is you find a pivot point, and then you switch numbers based on where they are relative to a specific number in the list, okay? And it's another technique. And then the most creative one I've seen is something called radix sort, which is that if you have numbers which are sufficiently small, you actually sort the last digit first, and then the second digit, and then the third digit, and then it becomes sorted. Okay, so just think about how that works. It's a pretty cool concept. And the way that you prove this stuff is through mathematical induction, which we won't go through today, but the time complexity of something like this is OD, which is O digits, okay? The number of digits you have. All right, that is it for today. We'll see you tomorrow again at 10. Thank you so much for your time.